We will see what is conflict serializability. Before going to that one, let us discuss about the conflicting operations. In the last video, thoroughly we have discussed, but I will summarize that once again. If two operations are said to be conflicting operations, then it must satisfy the following three conditions. That is, one is the operation, that is, any read or write operation should work on the same data item. Second condition is these two operations belongs to two different transaction. Out of these two operations, one must be write operation is the third condition. For example, you see here the same day, first we have to check whether these two operations work on the same data. Yes, here it is x, here also it is x, same data. Then we have to see whether these two operations are conflicting operation. Yes, here it is write operation, here it is read operation. Out of these two operation, one is write operation, so that we can say. And third condition, another condition is these two belongs to two transaction. Of course, it satisfies all the three above conditions. We can say this is a conflicting operation. The same manner, we can see here, first we have to check the data item. Yes, these two are same data item. And next to check two different transaction. Of course, these two are two different transaction. Out of these two operation, one operation is the write operation. We can say this is also a conflicting operation. The same way this also. So first we have to check whether the given operations are a conflicting operation working on the same data and two different transaction. Once it is over, then we can, so by summarizing, these are the three major set of data operations belongs to the conflict equivalent. So if a given schedule is can be transformed into another schedule by swapping the non-conflicting operation. That is, we will try to swap the non-conflicting operations, and we have to see is it possible to shift the operations so that we can get another schedule. That means a given schedule S can be transformed into another schedule called S dash by swapping non-conflicting instructions or operations. Then we can say S and S dash are the conflict equivalent. That means a given schedule S can be correctly converted into another schedule S dash, so that the transaction will be executed one after the other. So if a transaction, if a given schedule is a conflict equivalent schedule, then we can say this schedule is conflict serializable schedule. That means this schedule can be converted into some order in such a way that these two given two transaction will execute one after the other. Once it is, we have find that the given schedule is conflict equivalent, then it must, after converting this into another schedule S dash, this must satisfy two conditions. That is, the converted schedule S dash must have the same set of transaction of its original schedule S. We should not add or delete any actions or instruction with that, and the order in which the operations were there in S should not be altered in any cost. It should be of the same order. These are the two conditions also to be checked once if we have converted this into another schedule S dash. So we will take an example. Here is a schedule S having two transactions, that is T1 and T2. T1 have three instructions and T2 have two instructions or operations. Now we will try to swap the non-conflicting operations. We can start from the top or from the bottom. Let us start from bottom. That is, see here, this is read and this is write. Nearby operations to be swapped from the two different transactions. If you see this operation, this is conflicting. But we should not see the operation first. Instead, you have to see the data items on this operation. Here, this operation works on X and here it is Y. So, even though operations are conflicting, these two are working in two different data item, we can easily swap. This is not a conflicting operation. This is a non-conflicting operation. So that read y will go up, write x will come down. We have swapped these two. Now we swap because our aim is to bring this read y together to these operations and brought down this read x below, so that T1 will follow T2 or T2 will follow T1. Any one of the order we can make it up. Here see, there are two operations read. First you have to check the data item, it is X, it is Y, even though conflicting operations, two different data item, then we can swap these two. So read Y go up and read X from transaction 2 will come down. Now it is serialized. So S and S1 is conflict equivalent now. Now it is not at over. There are two more conditions to be checked. That means the set of transactions in S should have the same set of operation S1. That means here in T1 read X, write X and read Y. In S1 also read X, write X, read Y. In T2 original schedule read X followed by write X. Here also read X followed to write X. But the next condition is very important. We have to check all the conflicting operations of both the schedule so that the order should not be altered. How to check that one? Go to T1, check the first instruction, read X. What is the conflicting operation on the transaction 2? That is for read X, there is a conflicting operation write X. That means both are working in the same data. X, this is also X. And the operation is read X, write X. These two are conflicting operation. That means write X of transaction to be executed next to read X of transaction 1. That means, for example, this is what the schedule C. Write X second transaction is executed after read X of transaction 1. So, and see so this is okay. That is write X followed by read X of 1. Write 2 of X is followed by write 1 of X. Next you see, you take this operation, write X, check the conflicting operation on the next transaction. That means for write X, the conflicting operation is this read X. Both are working on the same data, X and X. These two are conflicting operations. In the original schedule, read 2X, that is read X of transaction 2 is followed by write 1 of X, that is write X of transaction 1. See here, read 2 is down and write 1 is on the up. So the order is not changed in the next converted schedule also, so that this is conflict serializable schedule and these two transactions can be executed without any problem. The third example we will see again a schedule. There are two transactions, both have three operations. We will start from the top. Okay, so see here, first we have to check the data item X and X, then check the operation read and read. Since both are read operation, it is possible to swap these two. So this read X came down, this read X went up. So this way we have swapped, and see these two now we are trying to swap. This data item is Y, this is X. No need to check about the operation, simply we can swap. So this read X came down, the read Y of the transaction 2 went up. Now again see, these two are two different data item. Then check the operation write and read. Two different data item, and there are two transaction. Even though the transaction instructions are conflicting, these are two different transaction, we can swap. These two are swapped. Now see, T2 will be executed first, followed by T1. Everything is serialized. Now we can say S is a conflict serializable schedule because we have converted S into this one. Once again, we will try to check the two conditions. These two schedule must have equal number of transaction. Of course, in T1 original schedule T1 read X, read Y, write X, read X, read Y, write X. In T2 read X, read Y, write Y, read X, read Y, write Y. Now we have to check the conflicting instructions are in same order. See, read X of T1, what is the conflicting instruction? It should be write X, but right side, see in the transaction 2 there is no write X. So there is no conflicting instruction, so that this order is converted order is well, and S1 are conflict serializable schedules. In example 4, again we have transaction 1 there are 4 instructions, and transaction 2 there are 4 instructions. Either we have to shift these two together here, or we have to bring down these two here. Either way we can work out. How to find out in which way we have to move? Not randomly from top or from the bottom. See, from here, if you are trying to shift these two transactions down, what you have to look is the next side, that is in the transaction 2, whether these instructions, that is this instruction must cross these two to come down. That's all. We have to check whether the both the instruction from transaction T1 and T2 have same variable. Yes. Then our possibility is less. And see, there is a conflicting instruction. There is a write text. Here also one write text is there. So there is a conflicting instruction between these two, so that it is somehow impossible to shift down this. Then we will try from the bottom. Either we can move these two by crossing these two, check the variables, the data item. Here it is y, here it is x. Even though the instructions are conflicting instructions, it is easy to shift to that, because variable is different, variables are different in the sense there is no conflicting instruction. That's why we can shift these two up. So what we have to do here is, we have checked these two. First we checked these two items are different items, so simply you can move. So read y came down, write x came down. Again these two we have to check. Of course data items are different, we can move up, so read x came down. Then these two to be checked, that is different data item, nothing to worry, we can move. Write y came up and write x came down. And here also once again these two we checked, and write y went up and read x came down. Now these two are serialized, that is T1 followed by T2. Again to confirm this, now the S is conflict serializable, that is yes, we have converted into S1, and two more conditions to be checked, that is the number of instructions in T1 should be equal to this number of instructions in T1 in S must be equal to the number of instruction in the S dash or S1. See here there are 4 instructions: read x, write x, read y, write y. Same way read x, write x, read y, write y. In T2 also it is same. Now the order in which the conflicting instruction to be executed to be checked very well. So that is, see here, read x, you take the conflicting instruction of read x is write x. That means write x to be executed after read x has been executed. See here in the scheduled S1, read x of T1 is first executed, next only write x of T2 is executed. So the order is correct. And see here, the write x of T1, the conflicting instruction is again this write x. So write x of T1 to be executed first, followed by the write x of T2. So write x of execute is means write x of T1 is executed over here and followed by write x of T2. Then here see the read y. The read y conflicting instruction is write y. That is read y of T1 to be executed first, followed by write y of T2. Read y is executed first and write y is this one. Again here write y, the conflicting instruction is write y. So that is write y on T1 to be executed first, followed by write y of T2. This way the conflicting instructions we can serializable using interchanging or swapping the non-conflicting instructions of two transactions. Thank you.